Hi everybody, and welcome to our lesson 5.3 on equivalent fractions. We're really going to start digging deeply into fractions. And when we talk about fractions, the technical definition is that fractions are numbers that are in the form of a over b, where a is not equal to 0. We'll unpack this just a little bit. So what they're saying is you need some number a over some number b, where a is the numerator, b is the denominator. The vinculum is that little line in the middle there, and what he means is simply divided by. So we're basically saying is a divided by b. Any number over the other number is divided by. Sometimes we like to keep them in that fraction form. So what we're really saying is a fraction represents just a part of a whole. So if I have 1 over 3, 1/3, that's saying if I am going to get a candy bar that's divided into 3 parts, I only get 1 out of the 3 parts. That was my life because I'm one of 3 kids. In this one, we look at 4 out of 12 parts. 4/12 is how we say it. So I would get 4 pieces of the 12 parts. I chose these 2 fractions because what we are talking about is equivalent fractions. These fractions are indeed equivalent, and let me show you why. Now, in a perfect world, Mrs. McKinley would have drawn her rectangles exactly the same. But this represents the 1/3. Okay? This over here represents 4/12. If you'll notice, I have the same area on both shaded. I just sliced these into smaller pieces. I'm still looking at the same amount. It's taking my 1/3 and saying, you know what, I want to make them last, so I'm going to divide them into 4 equal parts and eat 1 each day. So I'm going to take my 1/3 and divide them into 4/12 rather than just eating that whole strip of 1/3 of the chocolate. We call these fractions above equivalent because they are the same amount. They represent the same exact number. It's just writing it a little bit differently. If I say that my name is Mrs. McKinley, you know what that means. Other people, Mr. Heeman would walk in and say, hey, Heather. I'm still the same person. I'm still essentially the same, but I'm just called by a different name. So I can call 1/3 4/12, and it means the exact same amount. I'm going to take a look at paper folding, and what I have done here is I've just gotten an orange Post-it note and I've shaded half of it. So this represents 1 of 2 parts. Now, if I simply fold this paper into half again, you've probably seen this done, and if I look at the lines, now how many out of how many do I have? Well, there's a line right through the middle, right here. Now I have 2/4. I didn't change the shading at all. So now let me fold it again. Remember, I didn't shade anymore. I'm just slicing it up. And if you can see, I now have 2, 4, 6, 8 pieces, but I have 4/8. So 1/2 is the same as 2/4, is the same as 4/8. All of those are equivalent. They represent the same amount. It's just that they've cut the pieces into smaller and smaller pieces. And we can really do this till the cows come home. Now we're going to talk about making equivalent fractions by multiplying or dividing by a 1. Bring this to the top. And I'm going to call equivalent fractions EQs. And I like to make creative ones. For instance, you can do 2 over 2. If I get 2 halves, that's 1. 4 over 4. 4 fourths is 1. 8 eighths is 1. 123 over 123 is 1. I've just cut the candy bar into 123 little pieces. 613 over 613 is also 1. You get the point. We can do that infinitesimally until the cows come home, which they never do. So I can create an infinite number of equivalent fractions by multiplying or dividing fractions by a creative form of 1. So let's say that I want to take 1/2 and I want to multiply it by 1, or in my case I said I want to multiply it by 3 over 3. Well, if I go straight across, 1 times 3 is 3, 2 times 3 is 6, it's 3 6. These are equivalent. Now let's say I want to take that same 1/2 and I'm going to multiply it by the form of 123 over 123. 123 over 246, or 123 246ths, is equivalent to 1/2. Why do we need to do that? Well, it's coming up in when we add and subtract fractions. But we also are going to need to take fractions that are not in simplest form. If I notice this one, they're both even numbers. I know they can both at least be divided by 2. Simplest form is where the numerator and the denominator have the greatest common factor, which is 1. So if I look at 2/3, they don't have any factors in common except for the GCF of 1. If I have the numbers 7/8, if I look at the 2 of them, the GCF of those is 1. 16/24, the GCF of both of those is 8. So I'm going to divide it by 8 over 8, which is again a fancy form of the number 1. I draw a box around it to make it look like a thick one. So if I divide 16 by 8, I get 2. 24 divided by 8, I get 3. So the simplest form of 16/24 is 2/3. So what I'd like you to do down here, I'm going to pause the video and you can copy these down, and I want you to try to make 2 to 3 equivalent fractions, and this one is a little more open-ended. We might not have the same ones, but you do need to multiply 1/2 by the same on the top or the bottom. So if you wanted to do 100 over 100, you are going to get 100 over 200. That's your equivalent fraction. Down here, we need to take it to the simplest form. So you need to find the GCF of both of those and divide it by that fancy form of 1. Go ahead and pause the video. Try this for a moment. All right, really quickly, what I did with the 1 over 2, I did the 100 over 200 with you. I also did 16/32 and 5/10. You might have some different ones, but when you reduce it or when you simplify it, it should go back to 1/2. This one I multiplied it first by 2 because it's the most obvious one, 2/8, and then I also multiplied the top and the bottom by a 6 and did 6/24. Excuse me. You might have done some different numbers. That's just fine. For this one, I did 4/6. I always start there. Then I added a 0 because 20/30 is kind of fun. But then I multiplied it top and a bottom by a 15 over 15, and I got 30/45. There is just one answer on the bottom, and I put in my box what I divided it by. So I put it 3 over 3. I put a 5 over 5 here, and a 9 over 9 here, to get 4/7, 3/4, and 2/3. I want to demonstrate what might happen if you do 18/27, and let's say that you missed the 9 and you did a 3 over 3. It's not going to quite go down into the simplest form because now we are going to get 6 over 9. And now we can divide it by 3 over 3 again which will then get you to 2/3. So if you cannot find that GCF, or you want to, it doesn't bother you to do this a couple of steps, you can always do that. Sometimes if it's an even number, the first thing you do is just divide it by 2. That's just fine. Please come and see me if you do have any questions. A lot of you have experience with this, and we'll do a great job.